Hey guys, welcome to another video from ecopoint, and today I will be discussing certain statistics questions from IIT JAM paper 2023. The first question that I'm discussing in this video is question number 10 from that paper. Let M and N be events defined on the sample space S. If probability M is 1 by 3 and probability N complement is 1 by 4, then which of the following is necessarily correct? M and N should be disjoint. M and N are not disjoint. M and N are independent. M and N are not independent. Okay, so in order to solve for this question, we need to first of all put down what is the information. The information provided to us in this question is that probability of some event M is 1 by 3. Probability of some event N complement is 1 by 4. If probability of N complement is 1 by 4, that means the probability of some event N has to be 1 minus 1 by 4, that is 3 by 4, right? Okay, now we want to figure out which of the options is necessarily correct. And I can see in the options we are provided with disjoint and independence. So let's start with disjoint. But how do I figure out for disjoint and how do I figure out for independence? Well, you need to know the concept. Now, disjoint means that the intersection of the two events is phi. When the intersection of the two events is phi, that means the probability associated to this intersection should be 0. When this is happening, that means you can assume that the two sets are disjoint and two events are disjoint because they don't have anything in common. Their probability of something common happening is 0, right? On the other hand, for independence, what we need to check is that probability of the intersection is equal to the product of the individual probabilities. Basically, coming from the fact that if two events are independent, it means that the occurrence of one has no impact on the occurrence of the other. So the conditional probability A condition to B should be equal to probability A only. There should not be any impact of the occurrence of B on A, right? So this should happen. And that is why we get that we know the formula for conditional probability. So from that formula, you get that probability A intersection B should be equal to probability A into probability B. So what we want to check is whether these two events are necessarily disjoint, whether they are necessarily independent. Necessarily what will happen? Now, how do I move about in this question? Only information with you is M and N. The probability of M is 1 by 3. Probability of N is 3 by 4. You don't have the intersection with you. There is no other information provided to you. So all you can start off in this question is from the fact that probability of any event is always less than or equal to 1. It's greater than or equal to 0. Less than or equal to 1. Probabilities cannot be more than 1, right? So probability of the union of these two, M and N, also needs to be less than or equal to 1. It cannot be more than 1, right? Now, the formula for union is something which would include probability of M, would include probability of N, and will also include the probability of intersection. Probability M union N is basically probability M plus probability N minus probability of the intersection. So this should be less than or equal to 1. If this is less than or equal to 1, that means probability M is 1 by 3, probability N is 3 by 4, minus probability M intersection N should be less than or equal to 1. What I'm going to do here is that I'm going to make their denominator equal. So 1 by 3 is same as saying 4 by 12. And 3 by 4 is same as saying 9 by 12, right? So that means 4 by 12 plus 9 by 12 minus probability m intersection n should be less than or equal to 1. So that means 13. Okay, 13 upon 12 minus 1 should be less than or equal to probability m intersection n. In other words, what do you get from here? In other words, you get that probability m intersection n has to be greater than or equal to 1 upon 12, because this is what you get from here. 1 upon 12 is less than or equal to probability m intersection n. That means the intersection, probability of the intersection is greater than or equal to 1 upon 12. That means you do have something in the intersection. It cannot be the case that the intersection is phi. So this means m and n cannot be disjoint. M and N cannot be disjoint, and that should be the correct option. Option B is telling you that they are necessarily not disjoint. They cannot be disjoint. Have a look at the options. M and N are disjoint? No, absolutely not, because intersection is not pi. M and N are not disjoint. Yes, that should be the correct answer. And this is a part of the the series of questions where one option is correct. So once you get this, I think you know your answer. Secondly, you do not get exact probability for the intersection. So in order to find independence, you require that probability of the intersection is equal to product of the individual probabilities, but that's difficult to find here, okay? Since in this question, they are asking you particularly what is necessarily correct. So clearly that they're not disjoint is necessarily correct according to this information given to us. Independence, actually what is happening for the independence, let me just give you a brief on that also. Probability m into probability n जब हम करेंगे तो 1/3 into 3/4 होगा, यानी कि 1/4 आया. 1/4 is definitely greater than it's strictly greater than 1/12, right? 1/4 is of course more than 1/12. But the thing is, I don't have the probability for the intersection. So I require actually equal probability that if they are independent, then the probability of the intersection has to be exactly 1/4. We cannot say that there is nothing else provided to us. So therefore, that option is not the correct option necessarily. It can be true, it may not be true. We don't have the enough information, but we have enough information for us to be able to say that necessarily they are not disjoint. The next question for today is the 28th question from this paper. Let X be normally distributed and the parameters are 0, 1. Normal distribution parameters are mu and sigma squared. So this is standard normal random variable basically. And Y is absolute value of X. If the probability density function of Y is Fyy, then for Y greater than 0, square root of pi by 2 Fyy is. So all we have to do is, first of all, find out what is Fyy. That is, we need to find the PDF for the transformed random variable mod X. And once you have that, you can give the answer to this question very easily. The options given to us are very close to each other, so you have to be very careful while looking at it. E to the power minus y square upon 2, e to the power y square upon 2, e to the power minus y square, e to the power minus y by 2. Let's work on this question together. So X is normally distributed with parameter 0, 1. That means it's a standard normal random variable. Y the transformation is mod x. Now, FYY is the PDF of y according to the question, right? For y greater than 0, we need to actually find out square root of pi by 2 FYY equals to what? Well, I need FYY. I need the PDF for this new random variable mod x. Now, in order to find the PDF, you should be using here the CDF technique. Now, what is the CDF technique? So what you do when you have a variable like this, a transformation like this, you find the CDF for the random variable, and you should know that when you differentiate CDF for any continuous random variable, when you differentiate the CDF, you get PDF, right? So you first find the CDF for the transformed random variable and differentiate in order to get the PDF. Well, now X is standard normal. So that therefore, the information that we have is that fxx, the PDF for X, is equal to 1 upon root 2 pi e to the power minus half x square, right? So since we do have the distribution for x with us, we know it's PDF, okay? So this is the PDF for x. Now, use CDF technique to find the PDF for y. So CDF technique says that find capital FYY. Now, what is capital FYY? Probability y, the random variable y, is less than or equal to some value y. Okay, this capital Y is for the random variable. This is for the value that the random variable takes. This is what is CDF. CDF is always probability till a point, cumulative distribution function. Okay, so that's what is CDF. Now, what do you know about this random variable y? You know that this random variable y is actually mod x. So mod x is less than or equal to y, right? Now, what kind of x's will satisfy that modulus of x is less than or equal to y? ये कौन से x हैं जो इसे satisfy करेंगे? Well, mod x is less than y for all y's that are in between minus y to y, right? So whenever x is between minus y to y, I can say mod x is lesser or equal to y, right? Now, probability, that means of mod x less than or equal to y, will be same as the probability x is between minus root y and 5. Now, you must know about any continuous random variable that a continuous random variable, your probabilities are associated to density. Density means area, right? So if I want to find out probability between A and B, between 2 points A and B, how do I figure it out? I will find the area till B minus area till A, because density is nothing but the area. In other words, it's probability till B minus probability till A. And that will give me the area or the probability in between AB. Okay. So here it will turn into probability x is less than or equal to y minus probability x is less than or equal to minus y. Okay. अच्छा, अब probability x less than or equal to y क्या है? Well, probability of a random variable less than or equal to a value is basically its CDF, right? For that value. तो इसका मतलब हमारे पास यहाँ क्या आ गया? हमारे पास आ गया कैपिटल fx for the value y माइनस कैपिटल fx for the value माइनस y. ठीक है? सो हमारे पास बेसिकली आ गया कैपिटल FYY CDF of y for the value y in terms of CDFs of X. It's basically capital Fx for the value Y minus capital Fx for the value minus Y. Okay. How do you move from CDF to PDF in continuous random variables? By differentiating. So in order to get the PDF, you will differentiate. You will differentiate with respect to Y. So d fyy upon dy is equal to, when you will differentiate capital Fx with respect to y, so basically you will get the PDF, because derivative of capital F of x will be its PDF, right, for value y, minus, now derivative of capital Fx for the value minus y will be PDF for the value minus y, but mind you, since you have minus y inside, chain rule, so minus 1 also comes in and this becomes plus. So hence what you get is PDF of x for the value y plus PDF of x for the value minus y. अब आपको तो x का PDF पता ही है, it's standard normal, right? So this becomes 1 upon root 2 pi e to the power minus y square by 2 plus 1 upon root 2 pi e to the power minus of minus y square by 2. So which means that I am actually getting 1 upon root 2 pi, turns out to be common here, and you have e to the power minus y square by 2 plus e to the power again minus y square by 2. So that means you have twice of the same expression. So you get twice of the same expression. So 2 upon root 2 pi e to the power minus y square by 2. ये root 2 से cancel होगा. You will get root 2 in the numerator, root pi in the denominator, e to the power minus y square by 2. That is root of 2 upon pi e to the power minus y square by 2. What we have to find out in this question is square root of pi by 2 fyy. That will be equal to square root of pi by 2 into square root of 2 by pi e to the power minus y square by 2, and hence the answer is e to the power minus y square by 2. And this, my friends, is your option A. So option A is the correct option. I have tried to give you some, information about continuous random variable through this question. So I hope that will really help you guys. Okay. The next question we're going to work on is a maximum likelihood question. Let the probability density function of the continuous random variable x be fx, parameters are x and lambda times e to the power minus lambda x when x is greater than or equal to 0 and 0 otherwise, where lambda is greater than 0 is a parameter. If the observed sample values of x are, x1 is 1.75, x2 is 2.25, so on and so forth, the values are right here in front of you, then the maximum likelihood estimator of lambda is 5 by 2, 1 by 5, 5 by 12, 2 by 5. With the help of this question, you should be able to, work on any maximum likelihood estimator, okay? This is particularly a case of exponential random variable. As you can see, this is, if you have studied about exponential random variable, then you would know this is the PDF for exponential random variable, okay? Now, what is the maximum likelihood function? So you create a likelihood function by taking the product of PDFs at different values of x, and then you have to maximize. So when we maximize, what we do, we take the log of this likelihood function and then we maximize. When we're maximizing, what do we do? Like we optimize, we take the derivative, okay? We take the derivative, equate it to 0, and that will give us the value for which this will get maximized. So please write down likelihood function for the n sample of IID observations. IID means identical and independently distributed observations is given by the product of the individual PDFs. Okay. So that is what we are trying to say here is likelihood function. Generally, we write it as L of the parameter lambda x1, x2, if there are n observations, so till xn is basically the product. The symbol for product is this. So you write down that symbol for product. I goes from 1 to n. The function, the PDF that you have. Now PDF is lambda e to the power minus lambda xi, where I goes from 1 to n. That means, when you take x1, you will put x1 and then the product with the x2 one and so on and so forth. Okay. So this for us becomes product, since we are given 5 observations. So for us, this is I goes from 1 to 5, lambda e to the power minus lambda xi, where I goes from 1 to 5. To find maximum likelihood, what do? We take log. To find maximum of this likelihood, we take log. So therefore, what are we doing? We're taking log on both the sides. So take log of this function L, x1, x2, till xn. In this case, this is x5. That is on the other side, log product lambda e to the power minus lambda xi. I goes from 1 to 5. If the number of observations are 10, then I will go from 1 to 10. It's n, then it will go from 1 to n, so on and so forth. Okay. So you have taken log. That means what will we get here? Log of. So what is this product? Now expand. This product is lambda e to the power minus lambda x1 into lambda e to the power minus lambda x2, so on and so forth, till lambda e to the power minus lambda x5. Now, that means this is the same lambda everywhere, so it gets multiplied. We get lambda to the power 5. Now, base e is the same. So what you can do is you can add the powers, right? In the power, lambda is actually common. So minus lambda comes outside, x1 plus x2 till x5. You can write it like this, okay? Now, it's log of this product. So I can break it. I can say that this is log of lambda to the power 5 plus log of e to the power minus lambda x1 plus x2 till x5. Now by the properties of log only, this becomes 5 log lambda. And here log of e is actually log and e, they are entire of each other. So that means it's just the power that comes in here. So power is minus lambda x1 plus x2 plus x5 till x5 basically. Okay. Or in other words, it's minus log lambda minus lambda times x1 plus x2, so on and so forth, till x5. Now, this is our log of L, the likelihood function. Okay, log likelihood function. Now, which means this becomes, since the value of x1, x2, it's given to us. x1 is 1.75, x2 is 2.25, x3 is 2.5, x4 is 2.75, x5 is 3.25. I have these values, so I can just put these values out here. So this becomes 5 log lambda minus lambda times, just sum it up. When you will sum it up, you will get 12.5. When you sum this up, you will get 12.5. So lambda into 12.5, okay? Or 5 log lambda minus 12.5 lambda. Now to maximize, I need to differentiate this. Differentiate with respect to lambda. So when you differentiate with respect to lambda, you will get 5 upon lambda minus 12.5. Now, the first thing is first order condition, you will equate it to 0 in order to get the point. So equating this to 0, you will get 5 pi lambda is equal to 12.5, or in other words, lambda is equal to 5 upon 12.5. 5 upon 12.5 means you have 50 upon 125. 50 upon 125 would mean 10 upon 2.5, 10 upon 25, 10 upon 25, which basically is 2 by 5. So 2 by 5 is that value of lambda. We can call it lambda hat, that value of lambda, which will maximize this function. So therefore, from here you get your value that lambda is equal to 2 by 5, and that will be your maximum likelihood estimator of lambda. That's what you have to do when you have to find out maximum likelihood estimator. So D is the correct option, which is telling you 2 by 5, and 2 by 5 it is. Next question. Next question is from a set comprising of 10 students, 4 girls, G1, G2 till G4, and 6 boys, B1, B2, B3, B4, B5, B6. A team of 5 students is to be formed. The probability that a randomly selected team comprises of 2 girls and 3 boys, with at least one of them to be B1 or B2, with at least one of them to be B1 or B2. So what are we supposed to find? We have to find the probability that a randomly selected team of 2 girls and 3 boys, with at least one of them being B1 or B2. So in the boys, at least B1 or B2 should be there. There can be a case where you just have B1. There can be a case where you just have B2, or there should be a case where both of them are there, but one of them have to be at least there. Okay. So how do we go about this? These are your options, but let's just calculate it. Then we'll come to the options again. So we have G1, G2, G3, G4 are the 4 girls. B1, B2, B3, B4, B5, B6 are the boys. There are 6 boys. Team of 5 is to be formed, and the selection has to be, they want 2 girls. From these 4 girls, 2 girls, and from these 6 boys, 3 boys are to be selected. And we want the probability that 2 girls are there. It's a team of 5 people, 2 girls are there, and 3 boys with at least B1 or B2. What will this probability be? Whenever there is a probability question like this, first thing, you should try to find out the total probability associated to the scenario. Because see, probability is ultimately favorable cases upon total cases, right? So what is the total probability? What are we doing actually? That gives you a fair idea of what we are doing, and then what is the specific thing out of it which we have to take out in order to get our favorable cases. So, well, in total, we are selecting out of 10 people in total, 6 boys, 4 girls, so 10 people in total, we are selecting any 5. We are creating a team of 5, so we are selecting 5 people, right? That's what we are doing in total. But in specific, in our favorable case, what do we want? We want that 2 girls should be there. Okay, 2 girls should be there, and in boys we want that at least B1, B2 or B2 should be there. Okay, if we were just selecting, if we were to select 2 girls and 3 boys without any condition given to us, it would have been the case of 4C2 ways into 6C3 ways, right? It would have been the case of 4C2 into 6C3. Okay. Now the thing is 4C2 in our favorable case, in our case, 4C2 will remain the way it is because 2 girls have to be, selected, right? But this 6C3 is not what we need. 6C3 would contain all kind of cases, all the cases where even B1, B2 are not there. And we don't want any such case. I hope you are trying to understand which direction I'm taking you through. So basically, जब हम कहते हैं कि एटलीस्ट B1 या B2 होना चाहिए, तो उसमें हम कह रहे हैं कि ऐसा केस होना चाहिए कि मान लो सिर्फ B1 है चलेगा, मान लो सिर्फ B2 है चलेगा, along with other people, बट ऐसा कोई केस नहीं होना चाहिए जिसमें दोनों नहीं है. सो इन आर केस हमें क्या करना होगा, हम एटलीस्ट वाला जो केस है, एटलीस्ट B1 or B2 out of the 3 boys would actually mean that at least means total minus none. So it's at least case. So it is total minus none. So it becomes total minus the case. None यहाँ पे क्या मतलब होगा none का? Neither B1 nor B2. मतलब दोनों ही नहीं है. Neither B1 nor B2 is present. तो ये केस नहीं चाहिए हमें. ऐसा केस नहीं चाहिए जिसमें ना B1 है ना B2 है. हमें क्योंकि क्या केसेस चाहिए जिसमें एटलीस्ट या तो B1 हो या B2 हो. ओके, ऐसे होना चाहिए कि आउट ऑफ द 3 बॉयज एटलीस्ट या तो B1 हो या B2 हो. वी वांट देम इन द टीम. ओके, सो मतलब कोई भी ऐसा केस नहीं होगा जिसमें सिर्फ सिलेक्शन किस में से हो रहा है. अगर B1 B2 दोनों ही नहीं है तो दैट मीन सिलेक्शन किस में से हो रहा है, B3 B4 B5 B6 में से हो रहा है. ऐसे केसेस नहीं चाहिए जिसमें ऑल 3 पीपल आर कमिंग आउट फ्रॉम B3 B4 B5 B6. So that's not a case that we want. Okay, so which means what will become your probability, required probability? The required probability will be your favorable upon total cases. टोटल केसेस हमें समझ आ गए कि 10C5 कर रहे हैं हम इन टोटल, और क्या कर रहे हैं, यही कर रहे हैं. जो हमारा फेवरेबल केस है बेटा, फेवरेबल केस पे 4C2, 2 गर्ल्स आउट ऑफ 4 तो आ ही रही हैं. उसके अलावा टोटल माइनस नाइदर, ये क्या होगा, टोटल ways of selecting 3 boys out of 6 is 6C3. So these are the total cases minus. We don't want the cases where you are only selecting out of B3, B4, B5, B6. How many cases are there? That is 4 minus 4C3. ये क्या केसेस होंगे कि इन चारों में से सिलेक्ट हो रहे हैं ना, तीनों के तीनों इन चारों में से हो रहे हैं. दैट नंबर ऑफ केसेस विल बी B3, नंबर ऑफ केसेस विल बी 4C3. तो ये केस नहीं होने चाहिए हमारे पास. सो वी विल नाउ सॉल्व इन ऑर्डर टू गेट योर आंसर. Now we can simplify and get our answer. So this makes it 4c2 into 6 factorial upon 3 factorial, 3 factorial minus 4 factorial upon 3 factorial into 1 factorial, whole thing upon 10c5. 10c5 is 10 factorial upon 5 factorial, 5 factorial. 4c2 means 4 into 3 upon 2. And here it will be 6 into 5 into 4 upon 3 into 2 minus 4, whole thing upon 10 into 9 into 8 into 7 into 6 upon 5 into 4 into 3 into 2. Things cancel out. And what will you get? You will get from here, you get 6 into 16. 20 minus 4 is 16. 6 into 16. And in the denominator, things cancel out and you get 9 into 7 into 4. And that will give you, if you cancel out things now, 2, 3, 3, 8, 8 upon 21. Let's see if we have any option which we can relate to. Yes, we do have an option which you can relate to. It's 8 upon 21. Option C. That should be the correct answer. Next question is question number 39 from this paper. This question is testing you on your concepts. Very basic concept of CDF. Which of the following functions qualify to be a cumulative density function of the random variable x? And these are your options. So you will have to check each option. In this case, you will have to check for each option. Okay. Which option is the one wherein you know that, okay, this is not a CDF and which are CDFs. Or if there's just one which is a CDF, rest are not. We'll have to figure that out. अब ये देखेंगे कैसे देखेंगे कि CDF है कि नहीं है. So प्रॉपर्टीज आपको पता होनी चाहिए CDF की. प्रॉपर्टीज आपको गो बैक एंड प्लीज डू द प्रॉपर्टीज ऑफ CDF. CDF की प्रॉपर्टीज जो भी होती हैं उसमें से हम एक मेजर प्रॉपर्टी का यूज करेंगे. एंड वो क्या है? Everyone should actually know that. When you have a continuous random variable, basically CDF में क्या होता है? You are talking about probability of a random variable till certain point, right? अब ये जो probabilities हैं, ये as such discrete की तरीके से सोचोगे तो as such add हो रही हैं. इवन कंटिन्यूस में भी तो देखो कंटिन्यूसली चलती जा रही है प्रोबेबिलिटी एक्स की, तो ऐड ही तो होती जा रही है. प्रोबेबिलिटी इज अ पॉजिटिव थिंग, राइट? सो एरिया एडअप ही होता जा रहा है, एरिया एडअप होता जा रहा है. नाउ एरिया तो 100% ही हो सकता है ना, उससे ज्यादा तो नहीं हो सकता. तो सीडीएफ की प्रॉपर्टी क्या होती है कि सीडीएफ जहां से वेरिएबल शुरू हो रहा है, जहां से वेरिएबल शुरू हो रहा है उससे पहले की प्रोबेबिलिटी 0 है, और जहां तक आप जा सकते हो वेरिएबल में, जहां तक भी जा सकते हो वेरिएबल में, टोटल प्रोबेबिलिटी 1 से बियॉन्ड नहीं हो सकती. ओके, टोटल प्रोबेबिलिटी 1 से बियॉन्ड नहीं हो सकती. दैट इज व्हाई यू गेट टू मेजर प्रॉपर्टीज, या एक ही प्रॉपर्टी कह सकते हो इसको, दैट द लिमिट एज एक्स टेंड्स टू माइनस इंफिनिटी, योर एफ एक्स एक्स, माइनस इंफिनिटी का मतलब हो गया जहां से वेरिएबल शुरू हो सकता है. नाउ दिस limit has to be 0, and the limit as x tends to plus infinity, जहां तक भी x जा सकता है, अगर मैं वहां तक देख लूं CDF, तो बॉस 1 से ज्यादा तो नहीं हो सकता ना. सो CDF एट द मैक्स 1 ही तो रह सकता है, तो वहां 1 तक ही रहेगा. ओके, So therefore, these are the two major properties which you can use, apply here. All you have to do is that. So you can start with your option. So option A क्या कह रहा है? Option A कह रहा है fx is equal to 1 minus e to the power minus x when x belongs to 0 to infinity. And it's 0 otherwise. Okay. So हम क्या करेंगे? हम देखेंगे limit as x tends to infinity of capital Fx in here. Well, the limit will behave like 1 minus e to the power minus infinity. So the limit turns out to be 1. This is happening. Limit does turn out to be 1. Next up क्या करेंगे हम? We need to see what is the limit as x tends to minus infinity fx. Now actually in our case x is starting from 0. So do you think we'll be looking at minus infinity? No, we would be seeing that, when my variable is just starting, before that or around that, it should be just 0 and then uske baad area kuch aayega na. So for us, this will not be the case. The case in this question, in this option, the case with us will be, instead of minus infinity, we will be looking at limit as x tends to 0, the starting point. Now the limit will work as 1 minus e to the power 0. That is 1 minus 1, 0. Right, that's happening. So yes, in the beginning, the area is 0 and towards the end, it cannot be more than 1. That's what this is telling you, nothing else. ठीक है? अब ऐसे ही ऑप्शन बी देखते हैं. ऑप्शन बी में क्या हो रहा है भाई? ऑप्शन बी में आर फंक्शन CDF is it's 1 plus e to the power minus x to the power minus 1 and x this time belongs to minus infinity to infinity. So पहली प्रॉपर्टी हमारी हो गई limit as x tends to infinity fx. That will be 1 plus e to the power minus infinity to the power minus 1. So this will give me 1 to the power minus 1. That's 1 only. So this is happening. अब दूसरी प्रॉपर्टी फटाफट देख लेते हैं यहाँ पर. लिमिट x टेंड्स टू, इस बार माइनस इंफिनिटी वाला कॉन्सेप्ट माइनस में ही माइनस इंफिनिटी लगाना होगा, 0 नहीं लगाना होगा क्योंकि माय वेरिएबल इज कमिंग फ्रॉम माइनस इंफिनिटी. So this time limit x tends to minus infinity fx, we have to look at this only because my variable is starting from minus infinity. So अगर मैं यहाँ पर देखूंगी तो ये आ जाएगा 1 plus e to the power minus minus gives me infinity. So e to the power infinity whole to the power minus 1. So this gives me e to the power infinity is infinity. Infinity to the power minus 1 is 1 upon infinity. That means it is 0. So the limit turns out to be 0, which means that it's satisfying the property of CDF. इसी तरीके से ऑप्शन सी देखेंगे. ऑप्शन सी में हमारे पास है fx is equal to 1 minus x to the power minus 1 log x, where x belongs to e to infinity. देखिए इसीलिए आपको इस तरीके के फंक्शन दिए गए हैं जिसमें अलग अलग आपको डोमेन देखिए, किसी में 0 टू इंफिनिटी है, किसी में माइनस इंफिनिटी टू इंफिनिटी है, इसमें e टू इंफिनिटी है, ताकि आप सोचें उस डायरेक्शन में. And otherwise it's 0. So what do we have to do? We have to check limit x tends to infinity 1 minus x to the power minus 1 log x. Okay, तो ये हमारा आ जाएगा 1 minus ये 1 upon x हो गया बेसिकली log x, राइट? तो एक बात बताइए, 1 minus log x upon x as x tends to infinity क्या होता है? This is an infinity by infinity form. This is an indeterminate form, infinity by infinity. This is an infinity by infinity form, which means मुझे LH rule लगाना पड़ेगा यहाँ पर. LH rule लगाएंगे सब. So by that is L'Hopital rule. for indeterminate forms, and you will get this limit is basically 1 minus differentiate numerator and denominator, and now put the limit. So it's 1 minus 0, that is 1. So it is turning out to be 1 as your x tends to infinity. Now you have to check what happens when limit x tends to minus infinity. Well, this time my x is starting from e. So minus infinity में थोड़ी ना मैं interested होंगी. मैं interested होंगी कि what is the limit as x tends to the beginning. Beginning is e fx. So cumulative, of course, at the beginning the area should be 0. तो ये देखते हैं अगर ऐसा हो रहा है तो. Let's see. So 1 minus log x upon x है ये, right? So this gives me 1 minus log e upon e. So this gives me 1 minus log e is just 1 upon e. Well, this is not 0. So the limit as x tends to infinity was turning out to be 1, but the limit as x tends to e at the beginning CDF is not 0. That means this is not a valid CDF function. This is not a valid CDF function. हालांकि A और B ऑप्शन आ रहा था CDF. अब D भी देख लेते हैं because this is a multiple select question. So we must look at D option also. Now D option क्या कह रही है? हमारा function उन्होंने दिया है fx is 1 minus 1 upon log x as x belongs to e to infinity. And it's 0 otherwise. So let's check limit as x tends to infinity fx. This is 1 minus 1 upon, well, limit x tends to infinity of this expression. Log infinity is infinity. So this is 1 minus 0, that is 1. So this is getting satisfied. What about the other one? Clearly, by now you know that you will be looking at x tends to e fx. यहाँ पे upper bound, lower bound देखना जरूरी है. So that will be limit x tends to e 1 minus 1 upon log x. So that makes it 1 minus 1 upon log e. Log e to 1 ही है ना? So 1 minus 1, 0. So well, this is a valid CDF. In the whole analysis, what have we figured out? We have figured out कि A में कोई प्रॉब्लम नहीं था, B में कोई प्रॉब्लम नहीं था, D में कोई प्रॉब्लम नहीं है. These are all valid CDFs. But C is not. The question was asking us, which of the following qualify to be? So it's a multiple select question. A qualifies, B qualifies, D qualifies, C will not qualify. Okay. Next is a very interesting question. You have two uniform variable here. So X is uniform 820, Z is uniform 06. These are independent random variables, and Y is X plus Z and W is X minus Z. You have to find covariance of YW. That is, I have to find covariance of X plus Z and W is X minus Z. So that will be equal to covariance. When you have to find out covariance in these kind of scenario, A plus B, C plus D. So each covariance is added. So here you will get covariance XX plus covariance XZ minus covariance, since you have X minus Z. So you will also have minus covariance XZ or ZX, and you will have minus covariance ZZ. Now, if you know the formula for covariance, see covariance of XY is basically the expected value of x minus x bar, y minus y bar, right? So in case I have covariance x comma x, I have covariance of x with x, its expected value of x minus x bar into x minus x bar. So it's the expected value of x minus x bar square, which is nothing but variance of x, okay? So basically, this is nothing but variance x. This is nothing but variance z, okay? Now, coming back to that means covariance YW is equal to variance X plus covariance XZ minus covariance XZ. Any which ways, these were independent random variables. So covariance of X and Z is 0, but it's cancelling off. That's another thing. So that just cancels off. So you just have variance X plus variance of Z. Okay. So variance X, sorry, not plus, it's minus. Be careful with plus, minus, whatever is there. Now, you need to know what is the variance for uniform distribution. So if you have a uniform random variable in the interval, AB. So if it's uniform AB, then expected value of X is A plus B by 2, and the variance of X is B minus A whole square upon 12. Okay, we need to make use of variance. So here it will be, for X, the interval is 8 and 20. So it will be 20 minus 8 square upon 12 minus, for Z, it's 0, 6. So 6 minus 0 whole square upon 12. That means what are we getting here? We are getting 12 into 12 upon 12 minus 6 into 6 upon 12. So this is 12. And this, if you check, my friends, is 3, because from here you'll get 2 and then here 3. So that means 9 is what you get. 9 is the correct answer. It is actually an integer value that you are getting. 9 should be the correct answer out here. The next question again is a very quick and simple question. If you try it out simply, just don't make a fuss of that you have a normal distribution question. Let y be normally distributed with parameters 3 and 1. Now that means 3 is mu and 1 is sigma square. W is normally distributed with parameter 1 and 2. That means mu is 1 and sigma square is 2 for W. And X is a Bernoulli random variable with P equals to 0.9, where X is equal to 1. Bernoulli, of course, when X is equal to 1 is success and X is equal to 0 is failure. Let S be XY plus 1 minus X into W. Then expected value of S is, well, the expected value of S basically is the expected value of X, Y plus 1 minus X, W. So the expected value, by the properties of expected value, it is expected value of XY plus expected value of 1 minus X into W, which means that we are talking about expected value of XY plus expected value of W minus expected value of XW. Now, in this question, you will have to make a little bit of assumption out here. assumption of independence to be able to solve it. So assuming they are independent. Assuming they are independent random variable, your EXY will be equal to EX into EY plus EW as it is minus EX into EW. Expected values could be because of independence, expected value of the product is product of the expected value. Okay. It's a very important implication. It's a one-way implication. Okay. Independence implies this, but this implication does not imply, but not the other way around. So when random variables are independent, your expectation of the product implies expectation of the product is equal to, because covariance is 0. But this does not imply, it's a one-way implication. This implies this, but right-hand side does not imply the left-hand side. Now we have the expected value of all these random variables. We know because it's normal distribution, so parameter is mu. And also for Bernoulli, you must know that the expected value in Bernoulli is just P. Okay. So knowing that expected value of X is equal to just P, which is 0.9, expected value of Y is equal to 3, expected value of W. W was normal with 1, 2, 1. We just need to substitute the values here. So substituting 0.9 here, 0.9 into 3 plus 1 minus 0.9 into 2 into 1, sorry. So this becomes 1 plus 0.9 into 3 minus 1. So 1 plus 0.9 into 2, that is 1 plus 1.8, that is 2.8. So 2.8 should be the correct answer. The next question for the day. If X denotes the sum of the numbers appearing on a throw of 2 fair die, 6-faced dice, then the probability that X lies between 7 and 10 is equal to, round off to 2 decimal places. Well, probability X is between 7 and 10. In the question, we are given basically 2 fair dice and we are throwing them. Then X is the sum of the numbers that you see on the dice. Okay, so the number which is strictly between 7 and 10 is 8. So this will be equal to probability of getting 8 and probability that X is 9. So we just need the sum of probability X is 8 plus probability X is 9. Now what is the scenario? There are 2 dice. So you can say dice 1, dice 2. Now dice 1 can have 1, 2, 3, 4, 5, 6. Dice 2 has 1, 2, 3, 4, 5, 6. So therefore the sum could be just in a matrix fashion. You can see the sum. Sum will be 2 at this position when dice 1 is 1, dice 2 is 1. Then it will be 3 here, 4 here, 5 here, 6 here, 7 here. It will be 3 here, 2 plus 1, 3, 4, 5, 6, 7, 8. Here 4, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9, 10. The sum here is 6, 7, 8, 9, 10, 11. The sum will start from 7, 7, 8, 9, 10, 11, 12. Of course, the sum starts with 2 and can at the max go till 12. We are interested in the sum being 8 and 9. Now, the probability that the sum is 8, there are there are total 36 cases that you can make, 36 outcomes you get, right? So out of the total 36 places, there are 1, 2, 3, 4, 5 positions where you get 8, right? And for 9, there are 4 positions where you get 9. So the probability of getting 8 is 5 by 36. Probability of getting 9 is 4 by 36. That means the total is 9 by 36. 9 by 36 is 1 by 4. Or in other words, it is 0.25. Up to 2 decimal places, 0.25 is what you get. And that should be the correct answer. With these questions, you must have noticed that it's not that the questions are too difficult or something. Pick the right questions. The questions are of a lot of variety. You have a simple probability question wherein you have to use combinations somewhere. You have two dice question is there. You have question from normal variable, exponential variable, and they have also tested you on simple properties of CDF. So keep your basics clear. Things are not too difficult. I'm sure this video will help you out in the preparation for IIT JAM this year. Thank you very much.